Hello everybody, welcome back to the C programming tutorial. Today we will try to learn a new concept, a new data structure or a new data type, that is the arrays. So till now we have come across some of the data types such as an integer, a float or a character. So when we are talking about the data types or the data structures, we have three classifications of these data types. So as you see here, we have the primitive data types, that is the integer, the float, the double and the character. All of these belong to these primitive data types. And coming to the non-primitive data types, you have the arrays, the lists, stacks and queues. And another kind of data types, that is the user defined data types. While we talk about the user defined data types, we have the structures, unions, enumerations, etc. But now our focus is on the arrays, and we call it as a non-primitive data types because it is built by making use of the standard data type, that is either it could be an integer, a floating point numbers or a character data. So now let us look into the definition of an array. What an array is? An array is nothing but a collection of variables which belongs to the same data type. And it is a very commonly used, a popular data structure which stores data elements in contiguous locations. So what do we mean by saying contiguous locations is one after the other in the memory locations, the data is stored sequentially. And more than one element is arranged in sequence, so it is also called as a composite data structure. So when we talk about an integer, we know that an integer data type always represents a single value, and an array on the other hand will represent a set of values. So an array is a linear and a homogeneous data structure, we can say. So what do we mean by saying homogeneous data structure? Homogeneous data structure means that it contains a set of same data type values. So as you see, an array could be represented as follows, that is we have an array which has an array name and then a contiguous set of memory locations which would be allocated with these array values, and how to access these particular array elements we will be seeing later. So as I told you, an array is a homogeneous set of data. So that is why we have an integer array which consists of all integers, and an array of float data type will contain a list of only the floating point numbers or the real numbers. What are the characteristics of an array? One of the characteristics of the array is the definition itself, that is the array might belong to any of the data types, but this data type could be a single kind, that is a homogeneous data type. And an array size must be a constant value, that is an array can contain 10 elements or 50 elements or 100 elements, but whatever the number be, it should be a fixed size. So this constant value could be either given by a number or it could be given by a symbolic value. So this symbolic value would be, say I say size is equal to 5 and then I say array of size, meaning that my array will consist of 5 elements. And another characteristic is always contiguous memory locations are used to store array elements in the memory. That is sequentially the values are going to be allocated. Continuing with the characteristics of the array indexes always start with a 0 value. That is, when I say array, I am going to access each element of the array by naming its subscript or the index. So, the first value in my array would be array of 0. So, it would always start at the 0th location. And C does not check array bounds. So, we should take enough care such that we are not going to exceed the upper bound or we are not going to go below the lower bound. And it is always a good practice to initialize an array either to a 0 or a null value. Suppose we are not giving any value at the time we are creating the array or we are declaring the array. So, in a nutshell, when we have to say what an array is, we can say an array is a group of consecutive memory locations which has the same name and same data type. So, we have multiple values that could be accessed by the same name, but with a different subscript. And to refer an element, what we need to do? We need to specify the array name and the position number. So, this position number itself is the index of the array or the subscript of the array. What is the format that we use to access an array? That is, we have the array name with the position number. So, always the first element will be in position 0. As an example, suppose we consider an n element array which the array is named as C. So, we have the array elements as C of 0, C of 1, so on till C of n minus 1. Why it is n minus 1 over here is because we are starting the array element start from 0. So, 0 to n minus 1 would give me these n elements. So, suppose the values of the array elements, if they are going to be assigned in this manner, that is, we have a 7 element array. So, C of 0 which could be assigned with a value minus 45, C of 1 equal to 6, so on till C of 6 equal to 0. This could be represented in the memory such as this. That is, you have an array which is named as C. So, that is what we are trying to represent over here. That is, C is the name of the array. And how to access the individual elements in the array? We are trying to make use of the position numbers or the subscripts. These subscripts are always enclosed with a square bracket in this manner. Okay. So, when we are going to refer with an array with a single subscript such as this one, say C of 0 or C of 1, it means that I am trying to access an array element which has a single dimension. So, here as we had the values before, C of 0 is equal to minus 45. So, in the memory this C of 0 will have a value minus 45 and so on all the elements over here. So, how is the actual storage of this array done in the memory? We could see that we have the numbers say 1, 2, 3, 2 and 5. We have named this array as num, that is NUM, and since 1 is the first element in the array, the position number assigned to it is 0 and subsequently all the elements have their own position numbers or the subscripts or the index, that is 0, 1, 2 etc. And in the memory, suppose we have the address allocated for the first number of the array as 65516. This is a hexadecimal address that has been assigned, say for this variable 1. So, here we have 65516, that is the address of the first element of the array, and 65518 as the address of the second element of the array. Why it is so? Because we know that an integer occupies 2 bytes of memory locations. So, here the first integer occupies 65516 and 65517 memory locations. Okay, so that is a 2 byte data, and my second array element would be allocated with the address that is 65518, and so on. So, this is an integer array which consists of 5 elements, and each of these elements have been allocated with its own respective memory addresses. And as you see, whenever we say num of 0, if you skip this 0 also, only the array name num always refers to the first element of the array. So, if you skip this subscript, that is the square brackets that is enclosed within that as 0, if you skip that part and then say only num, that also refers to the first element in the array. Another similar example where we have a set of integers which is stored, that is these set of integers are 4, 6, 4, 2, 1. So, it is a 5 element array, and the address allocated for this array is suppose 65516, that is the starting address of the array. So, subsequently the array elements will be allocated with fresh addresses or with new addresses, that is for the integer data type, as I told you, it would take 2 bytes of memory locations. The next address would be 65518, which would be allocated for the second array element. And the starting address of the array is also called as the base address. So, as I told you, the base address could be accessed by saying or by calling only the array name. And how are these array elements treated in a C program? Are they treated in any special manner? No, the array elements are treated in a same manner as just as we use an ordinary variable. So, look at this example. C of 0 we have, which is assigned with a value 3, and we are trying to print the value of the first array element. C of 0 means that there is an array called C, and 0 says that it is the first element of that particular array, and here we are trying to assign a value 3 to the first location as a first element of the array, and we are trying to print the same. So, here I can say that it is print, since it is an integer data, I put a %d with C of 0, which means that I am trying to print out the first element of the array called C. Next, performing operations in the subscript, that is, are we allowed to have any kind of operations in the subscript portion or in the index portion? Yes, we could. Say I am referring to the fourth element in my array. How is the fourth element addressed? It is C of 3. Why? Because we start from C of 0. 0 is the first element, 1 is the second element, 2 is the third element, and 3 will be the fourth element. So, here when I say C of 3, it is always that I am referring to the fourth element of the array C. So, this fourth element could be written as C of 5 minus 2. So, here when I say C of 5 minus 2, 5 minus 2 is an expression. I am trying to put that expression in my subscript place or in the index place. So, when I say 5 minus 2, it is going to be computed and at value 3 would be obtained, and because of that I am trying to access C of 3. So, instead of referring that element as C of 3, I could also say it as C of 5 minus 2, or I could also say it as C of x, where x earlier would have a value 3. Next, coming to the array declaration. Having known what an array is and how an array element could be accessed, okay, we will now try to put these arrays as a part of the program. But as we have to put it as a part of the program, we know that we need to perform the data type declaration before using those data types or data structures. So, this is what we are trying to see now. We are seeing that how the arrays are going to be declared. We have the name of the array, the type of the array, and the size of the array or the number of elements in that particular array. So, here as you see, the format for declaring an array would be the array type, the array name, and the number of elements which is enclosed within a square parenthesis. So, as an example, in a C program, I could specify the array type as integer and the array name as C and the array size or the number of elements in the array as 10. So, what do we mean by saying by this declaration? We have an array which consists of integer data type and where the maximum number of integers I could allocate for this array is 10. In the same manner, we have another array declaration, that is float my array, and within the subscript we are saying the size of the array, that is 3284. So, what does this declaration mean? I have an array called my array which consists of floating data types, and the size of the array or the number of elements that I could place in my array is 3284 floating point numbers. Next, coming to this is an example where we are trying to declare a single array. Suppose I am using multiple arrays in my program. So, these multiple arrays could be declared in the same manner as any ordinary variable, that is by separating the variable declaration by a comma. So, here since it is an array declaration, I have to do it in the same format as we have seen here, that is specifying the array type, the array name, and the array size. This is one array, that is B is one array, and there is an array, another array which is called by name X. So, this X and B are both integer arrays which consists of 27 and 100 elements respectively. After the declaration of an array, its elements must be initialized. So, in the earlier case, that is as I discussed about the characteristics of an array, when we are declaring an array, it is always a best thing to initialize the array with either a 0 value or a null value. Suppose we are not giving any values at the beginning, because there are always junk values or garbage values that are going to be fit inside the array. So, in order to avoid that, better try to initialize the array values. So, this initialization of an array could be done at two different times, one at the compile time and one at the run time. So, how do we initialize these array elements at the compile time? let us see. So as you see, we have an integer array declaration, that is integer list of 4. So what do we mean by saying this? We have an integer array of size 4, and now we are trying to initialize the values for these elements. So how are we doing that? We are saying within a flower parenthesis the values. Here I do not have any other values, so I am just giving a value 0 to all these elements. So what happens over here when this kind of declaration is executed? We end up with this, that is the list of 0 has a value 0, list of 1 has a value 0, list of 2 has a value 0, and list of 3 has a value 0. So that means my entire array called list, which consists of 4 elements, are all initialized with a value 0. Can we not give it as, suppose I am initializing all my elements to a 0 value, so why should I give it 4 times like this? Can I not give only once? Maybe the question. Okay, no, it is not possible to give a single value in this parenthesis. Why? Because any one value corresponds to only one array element. So when I say my array size is 4, okay, I need to give 4 values for this array. So all those 4 values will go and sit in their respective positions like this. In the same manner, I could have an array which consists of a floating point data type. So that is why I make a declaration such as this: float total of 5 is equal to, and I am giving some values within the flower parenthesis, which means that each of these values, that is the first value 0.0, is going to be assigned to the first location of the array, or the is going to be the first element in the array total. So that is what you are seeing over here, that is a total of 0 will have a value 0.0, and the second array element, that is total of 1, will have a value 12.8. So it goes on subsequently with those values. So as my array size is 5, I have initialized with 5 values over there. What happens if I give excess values? We will see that later. Now coming to a character array. Character is again a standard data type. So I could have an array of characters in the same manner as I have an array of integers or an array of floating point numbers. So how do we declare a character array? I could make use of the character data type as the data type name, and this is my array name, and here within the square parenthesis I am not specifying the size, it could also be done, and I am initializing the values with some characters. Since it is a character data type, we have to enclose each of these characters by a single quote. So I have J, which is enclosed within a single quote, and A, C, K, all separated by a comma like this, which means to say that my name array, that is the character name array, the first location of my array will consist of a character J, and the second array element will consist of the element the character A, okay, so on. So what is the size of the array now? I have not specified the size over here. So the size of the array will be taken as the number of characters that has been given in this parenthesis. So what is the number of characters that has been given over here? I have J, A, C, K, and a null character at the end, as you see. A null character is specified by a \0. Okay. So here I have a set of 5 characters. So my array which is called as name over here will have the size of 5 character elements. Then in a similar manner I could initialize the value of a character array by a string literal. So here you see I am using a string literal called Jack and I am enclosing that within a double quote because it is a string. So any character data type in C is represented by a single quote and any string value is going to be represented by a double quote. So here I am saying character name and square, and I am not specifying the size of the array, and I am initializing with a string constant, that is Jack. So now my character array called name will consist of again 5 elements, that is the string literal Jack with an ending delimiter, that is a \0. The compile time initialization may be partial. In the previous examples we saw that the initialization was done for the entire set of elements in the array. That is, when I said an array which consists of 5 elements, all the 5 elements were given values, or an array which consists of 4 elements, all the 4 elements were given values. But sometimes this might also happen, that is, while we are initializing we may not initialize all the values, that is, for all the array elements I may not give the values. So at that time I say it is a partial initialization. Say for example, here we are saying an integer array which is called as number with a size of 5, that is, there are supposed to be 5 elements in the array starting from number of 0 to number of 4. But here as you see I am giving values, that is initializing this array with values 10 and 20, that is only 2 values I am giving to the number array. So what happens here is our number of 0, that is the first element of the array, will have the value 10. So this is the first array element value, and my second array element, that is number of 1, will have the value 20. And how about the other 3 elements? The other 3 elements will all have a value 0. So this partial initialization during the compile time would happen in this manner, that is, if not enough values are given in the initialization, then the other values will be assumed to be a 0 itself. In case it is a character array, as you see over here, we have an array called city and it is a character array and the size of the array is 9. So here I am trying to give values for this character array. The size is 9, but I am giving only 4 values over here. So my first array element will have a value, say B. So city of 0 will be equal to B, city of 1 equal to A, and city of 2 is equal to N, city of 3 is equal to G. So what happens to the next subsequent elements? I have not given any values, so it will assume a null character, that is a \0. So for all character values, for all character arrays, we are going to give null values. I mean, the system is going to give null values in case where there is a partial initialization, and in case of an numeric array, the system is going to assign with 0 values for partial initialization. And if the size is omitted during initialization, that is when we saw in a character array, that is we did not give the size of the array. So, if the size is omitted, then the size is going to be assumed by the system. So, as you see, for an integer array 2, integer sequence, that is seq is my array name, okay, and I am not specifying the size, but I am initializing with certain values 1, 2, 3, 4. So, there are 4 values that I have initialized. So, my array called seq will consist of 4 elements currently. Next, some sample array initialization. If we look into, we have int a of 5 is equal to, I am assigning all the 5 values for this, that is 2, 4, 8, 16 and 32. So, here it could be a static or an automatic declaration. Static or automatic declaration comes into picture where we are talking about the global and the local variables. Maybe you will be knowing about this more clearly in the next subsequent sessions. And in the second example, as you see, int b of 20, okay, we have an array called b with a maximum size of 20 elements. 20 elements. So, here I have values 2, 4, 8, 16 and 32, that is I am giving 5 values over here. So, the rest of the elements, okay, are going to be a 0. And the third example, if you see, that is an array called C, which consists of a maximum of 4 elements, but here while I am initializing with the values, I am assigning with 5 values, okay. So, here an error occurs, that is the C compiler is going to wake up with an error saying that too many initialization values have been specified. And here in the next example, as you see, you have an array called D with a maximum number of elements 5. It is an integer array again, and the initialization values that I am specifying here are 2 into n, that is expression I am specifying as the values. So, these expressions are going to be evaluated, and the evaluated values are going to be assigned to the array elements. So, here 2 into n, where n would have some prior value. So, that say for example, n has a value 2. So, 2 into 2 would become 4. So, d of 0 would take a value 4, and 4 into 2 would be 8. So, d of 1 will have a value 8. So, array initialization could be done in this manner. Then, as we discussed, initialization could be done at 2 points of time, that is one at the compile time and the other is the run time. Run time is when we are executing the program, the values are going to be assigned to the array. So, here an array can be initialized at the run time. So, in the program I am going to assign values. This is generally done when the array size is too big. Okay. So, here my array size is say 25, that is starting from 0 to 24. So, here you have for I is equal to 0, I less than 25, I plus plus. So, I am assigning 24 values to my array. So, array of I is equal to 0 means all the array elements will have a value 0, that is the first 25 elements of the array will be initialized to a 0. And an array could be assigned values or initialized values by a read function also, that is the scanf function. So, here I am saying I have an array called x which consists of 2 elements, and I am assigning values for them by an input, either by a keyboard. So here I can input the values, so that also says that I am initializing my array elements as the values the user is going to enter through a keyboard. Now I have one simple example over here which consists of an array A of a maximum size of 5, and as you see the code over here, that is for I is equal to 0 and j is equal to 10, both are the initializations that have taken place. There are two control variables over here, and then my termination condition is I less than 5, and my increment or updation of the control variable is I plus plus and j plus equal to 10, and I am assigning the value, that is a of I is equal to j. Just look into this and try to find out what the output of this would be. Any guesses? We'll just try to execute this program and find out what the output of this would be. I have two control variables I and j. So here I am incrementing the value of I by 1 and value of j by 10 all the time. And I am assigning the value j to the array element, so that is our program. I have an array called A which has a maximum size of 5, and I have two control variables I and j. I have initialized both control variables I and j to 0, and the termination condition is that I less than 5, and the updations of these control variables would be I would every time be incremented by 1 and j would be incremented by 10. And I am saying a of I is equal to j, and I am trying to print the values, that is a of the subscript, that is 0, 1, 2, etc. and what is the value that is assigned over here. So let us execute this program. There you see the output would be a of 0 is equal to 0, and a of 1 is equal to 10, a of 2 is equal to 20. So, that way the value of j is going to be assigned to I. So, this is one simple example that we have seen. Maybe in the next session we will look into the other examples. Thank you.